Okay. This is the example 9. You're going to have one that's just like it. And these are very similar to the kind of problems that we're going to get next class. It says, the liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, 90 units of vitamin C daily. A cup of a dietary drink, X, capital X, provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of a dietary drink, capital Y, provides 60 calories, 6 units of vitamin A, and 30 units of vitamin C. Set up a system of linear inequalities that must be satisfied in order to meet these minimum daily requirements for calories and vitamins. So you can see where all those numbers come into play, right? If you need 300 calories a day, that means you have to have more than or equal to 300 calories. Where are you getting the calories? You're getting them from these two drinks, right, which we're calling X and Y, which is very convenient because we're going to use the variables X and Y. So if you get 60 calories from each unit of the drink, that's 60 times X that come from the drink X. And you get 60 that come from the drink Y, so that's 60 times Y. We don't know what the X and Y are going to be now, but we know that when you add them up, they got to be greater than or equal to 300, right, in order to meet this requirement for calories. Right, for the vitamin A, the X drink gives you 12 calories per unit. So if you multiply 12 times the number of units of X, that tells you how much vitamin A you're getting from that drink. And you get 6 units of vitamin A from drink Y, so 6Y. The minimum requirement for the day is 36. And then this is the vitamin C, I guess. I might have that backwards. No, it's A then C. So it's 10 units of vitamin C per unit of X, 30 units of vitamin C per unit of Y. It's got to be more than 90 in a day. And most of the time when you see these at the end, which you almost always do in these kinds of problems, all it's telling you is we're not going to be dealing with negative amounts of cup of drink X or drink Y, right? We're only dealing with positive quantities, right? So, but what do these tell us in terms of our graph? Because we know we're going to have to graph these things. What's that? Well, it's telling you you're in the first quadrant. So we're not interested in any other of the quadrants. X is greater than 0, Y is greater than 0. That's the first quadrant. That's all we're interested in. Okay. So again, this is where it comes in handy that we have learned to graph these things by just find the X and the Y intercepts, right? This first one, this first straight line, define the X-intercept, cover up the Y term, 60X equals 300, so X equals 5, right? So 1, 2, 3, 4, 5. And cover up the X term, 60Y equals 300, so Y equals 5. 1, 2, 3, 4, 5. So we can connect those 2 points, and that's that line. Now we need to figure out where's the shading go with that. And it's not solved for Y. Test a point. Again, let's test the origin since that makes calculations easier. If I put in 0 and 0, then I've got 0 is greater than or equal to 300. That's false. So which side of that line am I going to graph? Not the side that has 0, 0. You're going to shade that side. Right? Okay, let's do the same thing for the next line. I'm going to change colors so we can see. Okay, for the X-intercept, cover up the Y term. 12X equals 36, so X equals 3. And for the Y-intercept, Y equals 6. Right, let's draw those two. And which side of that line are we going to want to shade? Okay, test a point. Let's try the origin. 12 times 0 plus 6 times 0 is 0. Is 0 greater than or equal to 36? so we're going to have to shade that side. Okay, so last line. Okay, the x-intercept is 9, right? 10x equals 90, so that's 9. 6, 7, 8, 9. And the y-intercept is 30y equals 90, so y equals 3. So we can connect those two. And which side of that line are we going to shade? I mean, put in the origin, right? 0 plus 0. 0 is greater than or equal to 90. No. So we're going to shade on this side. Up and up. Okay, so now we got to, and these two are telling us that we're in the first quadrant. So if I had to point out this area, it would be this, right? Like this. Goes down there, turns there. Okay. And so it's all of this area here. Right. If anywhere in this region, if you take your X and Y to represent how much of the one drink and how much of the other drink you're going to serve, you would be meeting all of the requirements that are here. Okay. Now, when we get to the next class, what you're going to find is that this area right here is called the feasible region. It's actually the domain of X and Y values that we're going to use to plug into another function. These points right here, everywhere you see a corner point, right, where these two straight lines come together, those are called vertices. And we will need to know what are those points. And the way you find out is you solve the system of equations, 2 equations and 2 variables. For example, like this vertex right here is the intersection of that line, the purple line, and the blue line. So that would be purple and blue were these two. So you would have to solve these two as a system to find out that vertex. And we will. We'll have to know what those points are. And we'll have to do the same thing for that point. Some of them you can just read, like that one, we would know right away that was 0, 6, because we graphed that as a y-intercept. And this one was 9, 0. So some of them you can tell right away, but some of them you have to solve a little system to figure it out. Okay? But for this time, we don't have to do that. We just have to be able to make this graph. And